linear differential equations of degree 1 but not constant coefficients. So recall we have t, which is our independent variable, time usually, and y, which is the function of dependent variable. And we'll have an equation of the type y prime, degree 1, so only one derivative, plus an expression, a function of t times y equals g of t. How do we solve this? Okay, so the solving this thing requires two steps. The first step is suppose that the equation were homogeneous in the sense that is y prime plus f of t y equals to 0. This is an equation of separation of variables that we have seen earlier, and it's quite simple, writing dy over dt plus f of t y equals to 0. And from here we move dy dt on the left and minus f of t y on the right, and now we do the separation of variables, so the y comes here and the dt goes up. 1 over y dy equals minus f of t dt, and integrate both sides as in the separation of variables. We integrate this guy here and we integrate this guy here, and what we have is the log of y, let's not worry about the absolute value for the time being, equals to minus the integral of f of t dt. We don't have an express formula for f right now because this is abstract, it's the general problem, so we'll leave it like that. And now we exponentiate both sides, and we have e to the log of y is y, so this is y is equal to e to minus the integral of f of t dt. Okay, so that's the solution of y prime plus f of t y equals to 0. So the second step is to modify this solution. So let's call this yh for homogeneous. The second step is to modify, in a sense, yh by multiplying it by a factor. So this y is a solution of our equation. This factor is called an integrating factor because it allows you to integrate the differential equation. I will explain here how to do it, but if you don't want, you can jump this ahead in the explanation and just learn that this is the integral of g of t over the homogeneous solution dt. And your final solution will be the product of this thing by the homogeneous solution, so e to minus the integral of f of t dt, and down here the integral of gt over homogeneous dt. Okay, so let me explain for those of you who are interested the integrating factor. Explanation for the integrating factor, and if you are not interested, jump ahead. Okay, so what we have is a homogeneous solution of this equation equals to 0, and we want to modify this by multiplying, so it becomes a solution of our equation, which is y prime, here is an h missing, plus f of t y of t equals g of t. So let's see, if I compute y prime here, y prime, this is going to be a function of t, and this also, so I have to use the product rule here, product rule. So what do I have? I have h prime yh plus h times yh prime. Okay, and we wanted to solve this equation, so we plug in this in here, and we have h prime yh plus h yh prime plus, so this is f of t times h times yh. This should be equals to g of t. This is simply here the derivative of y, and this is simply y, this part is y times f. Okay, so to do that, now we take common factor e, this integrating factor, common factor eta, and we have eta prime yh plus eta yh prime plus f of t, here is eta, so yh equals g of t. But now we know the homogeneous solution YH solves this equation up here. So this has to be 0. So we have eta prime YH equal G of t, and the integrating factor is equal to the integral of G of t divided by the homogeneous solution dt. Work out an example. If you have watched the part of the integrating factor, great. Otherwise, what we have is this differential equation, and to solve it, we first do assume the g is 0, and that's the homogeneous part, and then we multiply by this factor, integrating factor, and we get this solution. So let's work out an example clearly of this equation. Y prime plus 1 over t, y equals to 1, where y of 2 is equals to 3, for example. Let me rewrite with colors so it's clear what I mean for each of the terms in this equation here. So writing in colors, let's write y prime plus y equals 2. And now I use the red color. Oh, it's not coming. Okay, red color for the function f of t, which here is 1 over t. So f of t is 1 over t. And let's use a different color, say for example the green color for the g of t, which is 1 here, 1. So g of t as a function is constant, but is 1. And now we apply our formulas to get the solution. So first is the homogeneous. The homogeneous is the exponentiation of minus the integral of f of t dt. Now f of t, like I say, is what multiplies y. Y is not included here, it's only t, is 1 over t. So this is e to the minus the integral of 1 over t dt, e to the minus the log of t. Let's forget about the absolute value. Okay, so a negative exponent is a positive exponent in the denominator. Exponential and log are opposite of each other, so that's equals to t. Great, we got one. Now let's go for the integrating factor, which is the integration of gt over homogeneous dt. Okay, so sorry, I had done a mistake here. This is not t, sorry, is 1 over t. If we go here, then what do we have? Going to the integrating factor is the integral of the function g. G is here, is constant 1 divided by 1 over t dt. So becomes the t in the denominator, becomes up dt, so that's t squared over 2 plus c. Fantastic. Got the second one? Now our equation has solution given by the product of the integrating factor times the homogeneous solution, so will be t squared over 2 plus a constant times 1 over t, which are the term here and the term here. So t squared over 2, 1 over t plus c 1 over t. Let's rewrite this as t squared over t is 2 minus 1 is 1, t over 2 plus c over t. Now we use our initial condition given in this problem, which is simply y of 2 equals to 3. And remember, you have to always understand this when t is 2, y is 3. And our solution is here, y is equals t by 2 plus c by t. So we replace t equals to 2, y equals to 3, and what do we have? Y is equals to 2 over 2, sorry, a mistake here myself, I'm telling you what to do. The y should be 3, okay? 3 for y is 2 for t over 2 plus c over 2, meaning 3 is equals 1 plus c half, so 2 is equal to c half, c is equals to 4, and putting everything together here, we have y is equals t over 2 plus 4 over t, and that's the solution to your equation. So remember, for a general linear equation of degree 1 plus f of t, y equals to g of t, you have the homogeneous solution, which is e to the minus the integral of f, and then you have the integrating factor, which is the integral of g over the homogeneous, and then you have the general solution, which is e to the minus the integral of f times the integral of g over yh, which is the product of the homogeneous times the integrating factor. And that's all for today, folks.